Hi everybody, we're going to do day 7 notes today. Please find the page in your note packet that starts off with Roman numeral number 1, transformations. This is their day 7 notes. We need to pick apart the equation, find out what the letters A, B, C, and D represent, what they stand for, what kind of transformations are occurring in our trig equation. The negative in front of the A means there's a reflection in the x-axis or the midline, which is the D value. And the D value tells you there's a shift of either up D units, or if it's a minus D, it'll go down D units. C is what we're going to talk about today. Positive C is going to shift it to the left C units, and a negative C is going to shift it to the right. Remember that it is counterintuitive. It's the opposite of what we think is going to happen because it's a horizontal shift, which we're not, it's not new to us because we talked about that quite a bit with the parabola and the absolute value. So the transformations for the following example, remember we want to talk about the horizontal first, vertical last, everything else is in the middle. So we're going to first, the x minus pi over 2 means we're going to shift it to the right pi over 2. Please make sure that if it's given in radians, write it down in radians. If it was given as 90, then you want to say 90. If it was a 2, then you wouldn't say 2. So you want to make sure that your numbers match what's in the equation. The frequency has been changed to 3. We'll talk about frequency a little bit later. We're going to review it later. The third transformation that happened is now we have an amplitude of 4. So amplitude is 4. That means that it's going to be a steeper graph than the parent function. The negative means there's a reflection in the midline, which is at y is equal to 8. The entire curve, the entire graph got shifted up 8, which is our last transformation. The plus 8 means it went up 8. So you want to make sure that you have those in order. A couple of examples of what you might find in the regions with the horizontal shift. Given the parent function p of x is equal to cosine x, which phrase best describes the transformation used to obtain the graph of g of x is equal to cosine x plus 8 minus b? Notice it's inside the parentheses, so that's going to be a horizontal shift, and it's a plus a, so it went to the left a. Outside the parentheses is a vertical shift, and this went down B units. So we're looking for the choice that's telling us left A and down B. It should be choice 4. The next example, relative to the graph of y equals 3 sine x, what is the shift of the graph y equals 3 sine x plus pi over 3? We'll notice that this is a horizontal shift because it's inside the parentheses. Therefore, we're going to cross out the choices 3 and 4 because it's not a vertical shift. X plus means that's going to go to the left, so we're going to have to the left pi over 3. On the next page, we have one example of how we're going to shift a sine curve to the left pi over 2, and we're going to jot down that we want it in the interval. Let's write that again. We want it in the interval between 0 and 2 pi. I'm going to do this in 2 steps. The first thing that I'm going to do is I'm just going to graph the parent function y is equal to sine x. Then, once I have that graph, then shift it to the left pi over 2. And that's going to be my final answer. All right, so first of all, we're going to label the x and y axis. We want to make sure that it's scaled correctly and that it's labeled. Period is 2 pi. There was no change in my frequency. And because I know what's going to happen, the whole thing's going to move left 90 degrees. I'm going to jot down negative 90 also because we are going to the left. I'm going to change my pen to the gray because I'm going to graph the sine, the parent function, using a gray dotted line. It's going to be a light color because it's not my final answer. Remember, the sine curve starts at 0. It's O holo. It's going to go high at 90, 0 at 180, negative 1 at 270. Then at 360, it's going to back up to 0. Again, I'm not going to do a solid line. It's just a nice light dotted line because that's the one that I'm going to move. I'm going to change my pen over to blue. This is my final answer. Every single one of those 5 dots is going to be moved to the left. So my 0, 0, where you see I'm tapping blue, I'm going to move that to the left, so it's going to go to negative 90. The blue dot at 90, I'm going to move that to the left. It's not going to be sitting on top of 0, so 0, 1. I'm going to take the dot at 180 and move it to the left, so it's now going to be at 90. The negative 1 that's at 270, I'm going to move that over 90 degrees, and now it's going to be at 180. And 2 pi, which is at 0, is going to move to the left 90 degrees, which is now going to be at 270. When I connect those dots, I can start at negative 90, but my interval says only goes far left as 0, so that part doesn't count. So again, dotted line there, I can finally put my pencil down and graph the sine curve that got moved left 90. But I need to finish it off. I need to finish it off because my interval is telling me to go all the way to 2 pi. I understand how sine curves work, how cosine curve works. This is going to keep going, and it's going to finish at 2 pi because there's that more sine curve over on the right-hand side that everything got shifted to the left. Technically, we can erase everything. That's not the blue solid line because that's really not part of the graph. You don't have to erase it, but you can if you want to. So make sure that you understand that that is the final curve. Say, hey, wait a second. That looks like a curve like we know. You're right. That is the cosine curve. Any cosine curve can be represented as a sine curve with a shift and vice versa. Any sine curve can be represented as a cosine curve with a shift. So cosine x and sine of x plus 2 will give you the same graph. That's why they're called sinusoidal, because any trig graph that's either sine or cosine can be represented with a sine curve. All right, we're going to skip a couple of questions. We're going to skip tangent, we're going to skip that page, and we're going to go to this page, Roman numeral number 4, where we're asking for you to solve real-world problems with trig. Okay. Hopefully you went over the Day 6 summary that I gave you last time. I had posted the video, the explanation on Classroom, so make sure that you're going over that also because it'll help you out with these word problems. The Ferris wheel at the landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. The height h in feet above the ground of one of the 6-person cars can be modeled by the following equation, where t is time in minutes. Using h of t for one full rotation, the car's minimum height in feet is. Okay, to find the minimum height, we need to find range. And to find range, it's a 2-step process. To find range, we're going to go from the negative amplitude to the positive amplitude. Because before the shift of 80, amplitude is 70 means my low is a negative 70 and my high is a 70. So before the shift of 80, it was a sine curve, so we went up to 70 and down to 70. But then the whole thing got shifted up 80 feet. So now, when I go to look at my range, I'm going to add 80 to negative 70, and I'm going to add 80 to positive 70 to get my range, my correct range, which is going to go from not negative 10 to positive 10, 80 take away 70, 10 to 150. 10 is my minimum, and 150 is the maximum. So you want to make sure you understand. So they're not going to say range in the word problem. They're going to ask you for minimum. They're going to ask you for maximum, lowest, highest. You have to know that in order to find one of those, you have to find the range. Not asking this question, but I want to talk about really quickly this phrase right here. 7 minutes to make one full rotation. I'm going to review that. 7 minutes to make one full rotation. That means that period is equal to 7, because period is how long it takes for one full rotation. So you get onto the Ferris wheel, and it takes you 7 minutes to go all the way around, and you're going to end up where you started from 7 minutes later. Irrelevant in this particular problem, although some students may have used that 7 to come up with an answer because they don't know how to find range, so it's added information that didn't need to be used. But please make sure that you're aware of what that does mean. That is the period. That tells you how long it takes for the entire curve to happen. All right. So speaking of period, we're going to use that quite a bit in the next example also. Voltage used by most households can be modeled by a sine function. The maximum voltage is 120, so here's an important information. And there are 60 cycles every second. That seems important. There's 60 cycles every second. Which equation best represents the value of the voltage as it flows through the electric wires, where T is time in seconds? So we're looking for an equation. So it's going to be Y equals, well, we can say V equals the voltage. We have an amplitude, sine of B, and they're using T for time instead of X. Notice there's no vertical shift. Well, the maximum is 120, so we know that 120 is going to be the amplitude. The question is, what is B? All right. Again, let's review frequency and period. Period, I'm going to have the definition of period, and then I'm going to have a definition of frequency. Period is how long it takes for one complete cycle. We've talked about that for several days now. Period is, it answers the question how long it takes for one complete cycle. Frequency is the number of cycles that exist from 0 to 2 pi, from any 360-degree interval. And that's the B value. That is the B value that we need in order to be able to find the equation. We don't have that. All we know is there's 60 cycles every second. We also know that there's a really good formula that shows the relationship between period and frequency. It's 2 pi divided by B. And don't forget, B is the frequency. Well, we don't have either one of them. 60 cycles per second is not the period, and 60 cycles per second is not the frequency. But we're going to use the fact that there are 60 cycles in 1 second. Oops, let's spell second. To find out how long it takes for one cycle. Well, if 60 cycles can occur in 1 second, how long does it take for one cycle to occur? Hopefully you're saying a 60th of a second. That's the period. That's how long it takes for one complete cycle to occur. A little confusing, hang in there. We're not done. First of all, notice that none of them have 1/60th in the formula, in the equation, which is a good thing. It means, okay, we're not done. We're not wrong, we're not done. We're going to use the formula 2 pi is equal to, 2 pi, let me start that again. So period is equal to 2 pi divided by B. Well, I know period is 1/60. Set that equal to 2 pi divided by B, cross multiply to find B. And there it is. There's finally my B value, which will give us choice 4 as the final correct answer. That was a tough one. You want to make sure you understand the frequency and period. Some of the 4 choices were not very forgiving, and you just want to make sure that we're reviewing period and frequency. Right on the back, we have 2 more questions that we're going to do. The volume of air in a person's lungs as the person breathes in and out can be modeled by a sine graph. A scientist is studying the differences in this volume for people at rest compared to people told to take a deep breath. When examining the graphs, should the scientist focus on the amplitude, period, or midline? So let's see, it's a sine curve. And it actually says right here in the beginning first sentence, the volume of air can be modeled by a sine curve. So that means that volume will be on the y-axis, and x would be the time. So here's your sine curve. So we're measuring that distance. So which one of those 3? Is it the amplitude, the period, or the midline that measures this distance? Well, hopefully you're saying amplitude. Amplitude measures the distance from the midline. So amplitude is the distance from the midline. If it's a lot of volume, if it's a lot of air, it would hit the minimum. If it's not, then it's going to hit, if it's a lot of air, it's going to hit a maximum. If it's not, it's going to have to hit that minimum. Because amplitude has to be positive here, chances are the graph looks something like this, where you have the maximum volume is here and the minimum volume is there. But again, it's the amplitude. It's the amplitude that's going to measure the amount of volume of air in a person's lung as the person breathes in and out. Okay, The last example is going to help us do more word problems. Trig graph has a high of 20 and a low of 4. What is the amplitude? Not only are we going to look at the amplitude, we're also going to look at the midline. Again, I did go over this on my day 6 summary. The amplitude can be found by subtracting the 2 and dividing by 2 because amplitude measures distance. And to find distance, we subtract. Midline is the average. So you can actually think of the midline as the average. And how do you find average of two numbers? You're going to add the 2 and then divide by 2. And that's exactly what we're going to do with the max and the min to find the amplitude and the midline. So the amplitude will be 20, take away 4, divided by 2. The amplitude is equal to 8. To find the midline, it'll be 20 plus 4 divided by 2. So the midline is equal to 12. You don't have to use both formulas. You can see the relationship that I can find the amplitude by subtracting the midline from the max. I can also find the amplitude by adding the midline to the minimum, which again is that distance. So those are all kind of come together. So now that we have that, we actually can scale our y-axis really well, fairly accurately. 4 is the minimum, 20 is the maximum, and at y is equal to 12, we would draw a dotted line for our midline, our vertical shift, and then we'd go from there. Notice again, the amplitude is the distance between the midline and the high and the low. So it's both 8. 8 is the distance between 12 and 20 and between 4 and 12. We're going to move on and do the day 7 classwork. So please find that in your notes and we'll play that video next. Thank you.